3.2 Modeling a gas revision. A gas expands at a constant pressure from an original volume of 2 cubic dm at 22 degrees Celsius to volume of 4 cubic dm. Calculate the new temperature. As we know, PV, our T is constant for ideal gas. As the pressure is constant, we have V1, our T1, equals to V2, our T2. Temperature must be in Kelvin, so 22 degrees Celsius equals to 273 plus 22, that is 295 Kelvin. We don't have to convert cubic dm into cubic meter as they cancel out. So 2 over 295 equals to 4 over T2, and the T2 gives us 590 Kelvin. So in this question, note that we convert the original temperature into Kelvin. Question number 2. A gas in a container of a fixed volume is heated from a temperature of 37 degrees Celsius and a pressure 3 times 10 to 5 Pascal to a temperature of 87 degrees Celsius. Calculate the new pressure. It's ideal gas, so we have a PV over T equals to constant. As it is fixed volume, or volume is constant, we have a P1 over T1 equals to P2 over T2. And we need to convert the degrees Celsius into Kelvin. So T1 equals to 273 plus 37, that is 310 Kelvin, and T2 equals to 273 plus 87, that is 360 Kelvin. Now we can substitute values. P1 is equals to 3 times 10 to 5. T1 is 310 equals to P2 over 360. And that gives us P2 equals to 3.5 times 10 to 5 Pascal. And again, we had to change temperature into Kelvin. A fixed quantity of gas of volume 3 times 10 to minus 3 cubic meter, pressure 3 times 10 to 5 Pascal, and the temperature 300 Kelvin expands to a volume of 4 times 10 to minus 3 cubic meter and the pressure 6 times 10 to 5 Pascal. Calculates the new temperature of the gas. As it is a fixed quantity of gas, or the mole number is constant, we have PV over T, which is constant. That is P1 V1 over T1 equals to P2 V2 over T2. Temperature is already in Kelvin. We don't have to convert. So 3 times 10 to 5 times 3 times 10 to minus 3 divided by 300 equals to 6 times 10 to 5 times 4 times 10 to minus 3 divided by T2. And T2 equals to 800 Kelvin. So the new temperature of the gas is 800 Kelvin. Above figure shows two isothermal curves for equal quantity of two ideal gas. State and explain which gas is at the higher temperature. We draw vertical line that intersects two isotherms at 2 points like this. At these points, both gases have the same volume. As the quantity of the gas are equal, N is same. So PV equals to nRT, as it is ideal gas. Rearrange P over T equals to nR over V. As N is constant, R is constant, and the volume is constant, so P over T is constant. That means pressure is proportional to temperature. So that's P2. This is P1. P2 is larger than P1, and we know that pressure is proportional to temperature. So T2 is larger than T1. So the point on the blue curve, upper curve, has a higher pressure, so it must have the higher temperature. The Kelvin temperature of a gas is doubled. By what factor does the average speed increase? So kinetic energy equals to 1/2 mc squared. C is velocity, and which is also equals to 3/2 kBT. From here we can see that the mass is constant and the Boltzmann constant is constant, so we have a c squared proportional to t. So we find that when t doubled, then c squared will double. So c itself will increase by a factor of root square of 2.